Okay, knowing the integrated rate laws is going to help us determine our K value. Um, so once we plot a line based on which order it is, we can determine the K, which means that we can determine the slope and then determine our K value. So for zero order, the rate law does not rely on the concentration, or the rate does not rely on the concentration. So the rate is equal to the slope, and our slope, or the opposite of our slope, is equal to K. K has to be positive, so if our slope is negative, then negative slope equals K. Our first order rate laws, for our first order reactions, the rate is equal to K times the concentration. For the first order to be able to plot a straight line, we will do the natural log of A. And so what we're doing is we're plotting the natural log of A at a time interval versus time. And so our K would be equal to the negative slope of this. And then our second order rate laws, rate is equal to our constant times the concentration squared. So for us to be able to plot a straight line for this one to determine K, it is 1 divided by the concentration of A at the time. And then in this case, it is an increasing line, so our slope will be equal to K. And I have the math here, the rearranging of the equations. So if we're not sure what our rate law is by looking at the experimental data, then what we should do is figure out, we already said that the zero rate law is basically just our concentration versus time. For our first order rate laws, it is the natural log of our concentration. So if you went through and plugged in the natural log of 0.799, this is what you would get. And then for our second order, it is 1 divided by the concentration. So 1 divided by 1 is 1, 1 divided by 0.894 is 1.119, and so on down the line. Now, if you want to determine very quickly, just by looking at our data, which order it is, we know that this is not going down by equal amounts. It went down by 1.6, then by 0.09, and so it's not going down by even amounts each time. Over here, what we see is this goes down by 0.112, again by 0.112, 0.112. This one's 0.113, but that's within a reading error. Again, 111. So this one's going down the same amount each time. This one over here is increasing by 0.119, and then by 0.133, then by 2.52. So this is not the same. So these are not equal increments. These are equal increments. So this would be a second order rate law. I'm sorry, that is incorrect. That would be a first order rate law. This would be first. If this one had been going down in equal increments, it would have been a zero order. And if this one had been it, this would have been your second. If you can't determine it initially, and in the lab you're going to do on Monday, you are going to have to determine what order, you're going to have to determine K, which means you have to determine what order the reaction is. And the best way to do it is plot each of these graphs, and whichever one gives you the straight line is the order of the reaction. Half-lives. This is a first order half-life. This is the only one you have to memorize. You should be able to do 0 orders because however long it takes for that concentration to go down to half, and I can give you that formula next time, but that one should be pretty much easier to do. But this is the only formula that's on your formula sheet, so it's really the only one you have to kind of know, and that is the half-life of a first order is equal to 0.693 divided by our constant K. So if we can determine our K, we can determine how long it's going to take for half of it to go away.